Hello everyone, welcome to the November 2015 meetup. Tonight we've got 3 talks. First up we have Sam, then Colin and Bowen, who's in the crowd somewhere up the back. We're at ThoughtWorks, so thanks to ThoughtWorks for hosting us. They've hosted us 3 or 4 times now, so they're a good community supporter. Tom, did you want to say a few words about ThoughtWorks?
Hi everyone, welcome to ThoughtWorks. The loo is through the past the lift where you came in if you'd like to go there. The fridge is in the kitchen if you'd like to raid it and have beer. Make yourselves at home. As ever, ThoughtWorks is seeking to hire smart Infracoder type people. If you would like to talk with us about that, then you can talk to one of the many ThoughtWorkers here over beer and pizza we'll be having that. I hope that was a short enough benefit.
Thank you. So we'll kick stuff off because we've got quite a few speakers. Sam is going to talk about HAing all the things-ish.
Yeah, cool.
So thanks, Sam.
So I'll warn you straight up, I haven't run through this talk. I wrote most of it last night when I remembered that I was doing a talk today, and it's mostly stock photos. So I apologise in advance. So sort of went down a road of looking at the Linux HA stack, which I hadn't been impressed with in the past, but hadn't had enough time to sort of go down with. So this is sort of super high level, what are the tools called? What do they do? What don't they do? And what can you do with them? It's not a tutorial on how to do it, and I give you a link to a tutorial that is totally read the bloody manual and you'll come away shit, I wish I knew this 10 years ago. So it can be a really complex subject, but I think the message I want to give is that although HA and clustering and things can be complex, it's also not so complex that it should scare you off. And there's lots of situations where people have really basic single points of failure in a network or a system design that really doesn't really warrant, given how easy it is just to create a simple cluster or a simple failover of something. And lots of us do that with things like failover IPs using various mechanisms, and often that kind of depends on the kind of thing that you're making, whether it's HA proxy or you're doing a CART IP address failover or something. So who am I? Most of you probably know me. I'm not sure if that's that contrast is all right. Obviously the Info Exchange did lots of storage stuff this year. Sort of in last year was looking at enterprise storage to replace our SANs, traditional SANs, and everything sucked and was really expensive, and all the vendors wanted to screw us. So we had a look at is it viable to build your own thing these days, or are we going to go down some money pit of managing this thing? Turns out that the Linux HA stack has really massively evolved thanks to a particular few individuals in the Red Hat community, and SUSE, whatever you want to pronounce them as. They've really put a lot of effort in over the last 3 years or so, and it's actually bloody easy and it's rock solid. It's really nice. So I'm sort of known for clustering, and
I can't find that tweet online.
Because Joel deleted it because he's paranoid. Someone will know that he defecates. So yeah, sort of known for clustering things, not always the right way, but going around it. So before explaining about the tools themselves, just kind of what can you do? So I mentioned floating IPs. Maybe you've got a file system or a an LVM, logical volume, or something like that on top of some disks, or some storage, or some virtual storage. And this applies to whether you're running Linux OSs and AWS, Rackspace, physical hardware, Raspberry Pis, whatever. Actually, I don't quite know the Raspberry Pis. I don't know if they can do it. Basically, any systemd or LS standard, traditional LSB startup script, you've got a service that needs to stop based on some parameters and start based on some parameters with some config, but only after maybe X storage is available between a number of hosts. You've got Postgres here and Postgres there, and not Postgres everywhere. Sorry, there you go. And you want to fail over it, and maybe you don't like the way that standard Postgres is failover. Its replication is good, but its failover is kind of shit, it's bash script or something. You've got VMs, maybe you're on Xen or KVM, and based on some load, maybe you want to just look at CPU load over 10 minutes or something like that, and you say, oh, I kind of want to just say you want to scale up something that you think only would be available in say a managed hosting environment where you call an API based on a number of CPU requests. Maybe when load has been at 2 for 10 minutes, you just spin up another instance of application X over in some other physical place, or maybe you spin one up in Rackspace because AWS is performing badly or something, God forbid. Network services, various other things like that. Pretty simple. And for the purpose of this talk, I'm going to keep it like as simple as possible. So I'm just going to talk about active standby. It's not actually that much more complex to go active, depending on like what your data is and how you need to look at split brain scenarios and stuff, which I'll go into slightly. So we're just going to talk about a thing that is over here, and like how do we get it running over here? So like there's a node, an AWS instance, a physical piece of hardware, whatever, to node 2. Which in this case, in the scale of things, I'll be talking about 2 key pieces of the puzzle, and it is a puzzle, which is Pacemaker and CoreSync. So they're parts of the Linux high availability framework. So Pacemaker. So I'm sorry about kind of like how wordy this bit is, but it really is the best definition that Pacemaker is the thing that starts and stops services. That's really, really key. So like your database, your mail server, your virtual IP, your file system or whatever, your system D script, and it contains logic for ensuring that both are running or running in the way that you want them to or not running, and that they're only running in one location if that's what you want, or maybe you want it running in all locations. Okay? Second part is CoreSync. And I'm going fast because there's quite a bit of content, and you can totally check this out from that silly QR code at the start or afterwards. And CoreSync, which is the second piece of this, like the main part of the puzzle, is sort of the messaging layer, and it handles like the messaging for the state of the cluster. If you ever start playing with these tools, it becomes really easy and obvious to understand straight away. It's kind of hard without using them to explain them. I think like Andrew, who's here in Melbourne, he's not here tonight, is he? No, okay. Who wrote most of Pacemaker for Red Hat and SUSE and all these people that use it now. That's a quote from his blog, which is fantastic. Just essentially, he described it as the bus, but between nodes. I don't know if that's the best description, but
For us Linux people, what else is it?
Message bus, essentially, okay, but not as like cool and funky as like and fancy ESP that does all these dynamic things. It's designed for this purpose and this purpose only. It sits very nicely glued in with Pacemaker. Back in the day, you might have heard Heartbeat, which was kind of the precursor to Pacemaker. Good naming standards. So like, here's an example of something really super simple, like the most basic thing. I have a virtual IP or a floating IP, and I have a service, which I've just log stash, whatever, it's some hipster thing, right? And you've got something, you've got a file system. In this case, if you don't know what DRBD is, it's just, essentially it's a replicated block device, but let's just pretend that your file system is available there, and you want to make sure that it's replicating to the secondary device because this is your data, and you want to make sure that these service and the virtual IP can fail over. Really simple active passive stuff at the OS level or at the kernel level, and it's facilitated by a Pacemaker and CoreSync sitting on top of 2 nodes. So the things that kind of build up or describe a lot of, like, I guess, the objects within the cluster are resources, and they're provided by a thing called the Open Cluster Framework. If you Google, or what's a better thing, DuckDuckGo, I was going to say Bing, like Linux HA, a thing that I'll warn of really early on, and don't forget this if you take one thing away, is that there's tons of misinformation, and it's not because people are like crazy idiots that do things the wrong way, it's because the rate at which Linux HA and clustering has evolved in the last probably 5 years, mainly the last 3 years, compared to the amount of data and historical information out there of people playing with the Linux HA stack is greatly different. So if you Google Linux HA, it'll take you to like linux-ha.org. Pay note to the thing that says at the top, this is deprecated information, go to this URL. Really, there's only like, there's a source that you should pay attention to above all others, which is clusterlabs.com or .org, depending on which site you land up on. And I'll give you some links to that at the end. So resources, objects within the cluster. Resources, they describe things for Pacemaker, which is the cluster object manager or the cluster state manager, about different possible sort of services and objects which can exist within the cluster, and how you can interact with them. So what metadata or pieces of information can you pass to them? For example, let's say you're managing an iSCSI LUN, what parameters can you pass to it? Well, I've got a serial number, I've got the list of authorized initiators on the other end, whatever. If you're talking about a file system, what file system is it ext for, where is it sitting, on what block device? If it's an IP address, what's the subnet, what's the IP, blah, blah, blah. Those are all sort of resources, and they're facilitated by resource agents, which are provided by the Open Cluster framework. Essentially, you can write your own ones really easily, like we've done it. It's there's like a template or a set of sort of standards that you have to conform to. It's mostly Python and Bash, but it's not hard and it's not gross Bash, so it's sort of like the minimum viable thing you can do to describe an object. An example of a couple of these that exist, so the resource standards, Open Cluster Framework, LSV, traditional startup scripts, service, I don't actually know what that is, so I shouldn't have put it in there. Systemd, so Systemd services, like I gave you Logstash before, you'd start Logstash out of Systemd unless you're running something old. Stoneth, which I'll get to in a bit. And then resource agents like file systems, IP addresses, what's sort of happening at that layer, LVM, postfix, whatever, something else that you're running in there that has like a described resource and management sort of framework built around it. And it's pretty easy to get information about each one, like whether you want to check it out on GitHub under the source for like what each resource agent does, or you can just type it in and it will tell you, and I've cut off the bottom here, like a whole heap of information about like what parameters it accepts and things, but IP address 2 manages a virtual IPv4, IPv6 address. So it's a floating IP resource. You pass things like your IP addresses, as I said, the subnet and stuff. So you can kind of get all these bits and kind of plug into how you want to describe your service or your environment, and then you can kind of locate them together. So this comes back to like making sure that things are kind of started. So say you don't want Redis started here unless the file system is available that contains the Redis database and it's able to start the IP, or the IP address doesn't exist anywhere else, as in you've done some sort of ping sweep or something else, something you've ensured the state that IP doesn't exist somewhere else. So you'd make a constraint that say 2 resources within the cluster need to live together, need to exist together, and in what order. Sort of sweeping over this because really to do it, you should read the manual. It's not hard by any means. I mean, I read it, and it's not a complex thing at all. But if you can think that you just wouldn't want resource Y to start before resource X, it's a really important part of designing your clusters. And from that, obviously, like how do you know when a resource has failed or whatever? There's the resource monitoring. So I guess how often do you check each resource within the cluster? So Pacemaker that manages, that sort of glues in everything together and sort of knows about the state of the cluster. It's the sort of the cluster database or database manager, if you will. When it's checking to see, oh, is Redis still running? How is it doing that? And how often? And what happens if it's not there? In this example here, it's creating an IP address, and when you're creating it, you're sort of monitoring that IP address exists, and the timeout for not being able to check it is 30 seconds. But sort of how are you checking that? By default, each resource provider or resource agent has that sort of description of how things are measured and monitored. You can override all of them. For example, this one here might be that it checks the Linux kernel to see that that IP address is available on that machine. It might not be up to your level where maybe you want to make sure that it's pingable from some other machine in the cluster or something like that. Generally, I found the defaults for most of the clusters are really sane. For most of the resources, I should say, not clusters. I'll jazz over it, but basically, yeah, any resource, whether it's Redis or a file system or something, say a node in the cluster can't bring it up for whatever reason, what's going to do? It's going to restart it in this case. If it can't stop it, it's going to block. So it's going to stop the cluster from being able to shift that resource. So if I can't stop the IP, we don't want to start the IP over there because we're in a resource conflict. Again, sort of jazzing over it, and it's kind of like it's a lot of information, but it kind of all ties in together when you start playing with the tools. And to do with those like IP conflicts in the way that you don't want resources started in 2 places at once, which is the classic split brain in Stoneth. So shoot the other node in the head is the classic Stoneth sort of thing. What if a node can't ensure the state of its peer? And that's really what it comes down to. Let's say you have a file system or a block device. Let's say it's a storage server, because that's what we run all this stuff with. You built your own SAN or storage server, or you're providing some sort of clustered storage or something to someone, and you don't really want nodes to be able to write to that file system or object system in 2 places, because, well, obviously you can have disparate data around the place, and it's hell. like a split brain scenario is absolute nightmarish. It's anyone's worst sort of fear, I guess, when dealing with storage. And by ensuring the state of the other members of the other nodes within the cluster, which is usually done like really ruthlessly by powering off the remote system, or shutting down the instance or whatever in some sort of forceful way, so that if that instance is kind of crashed and it's still broadcasting that file system or whatever is available, so that nodes are able to write to it. How do you make sure that they absolutely can't write to it? Even if the service goes down, a service going down, believe me, is way better than a service writing to two different places. And it sort of looks like this, it's like two servers or two services, and they're kind of constantly holding a gun to each other's head, and sort of going, well, you still there? You still there? You still there? You still there? And when the other one stops, broadcasting or being available via whatever resource methods you've defined, it shoots the other node. And I'll get into that a little bit in a moment. There's a whole heap of different ways you can kind of do it. If you're dealing with physical servers, like the most common way in traditional storage units is that you will like power off the remote, either the whole remote unit, or you'll cut the power to the network connection. So whether that's like whether the network card, the remote device has a link disconnection circuit, or whether you have something like one of these, which is just like a really overpriced piece of shit that is on your network, and it physically turns off the power to that other storage unit. It's pretty ruthless. It's pretty ruthless. There's other ways. We came up with this one, which is really simple. It sends a serial signal to reset the switch on the motherboard of the adjacent physical node. So this is it just goes into the motherboard on the adjacent supermicro node or whatever, and if it needs to turn it off, it sends a reset signal or holds down the power switch for X number of seconds. So there's a whole heap of different ways you can sort of do that. Obviously, when you're dealing with something in the cloud, or some sort of something that's API driven from the units that you're running your storage or your clustered service on, you can generally call an API or whatever and ensure that it's shut down, and then not start the resource anywhere else until you've seen, you can measure that it is down, until you've ensured that state. I've got a couple of little demos that might make more sense than me riveting on. And just before I go into them, I'll show you a lot of information in a really short period of time. So there's that Stonor thing that I was talking about. Here's like a ugly visual diagram of like how a storage cluster might work. So here we've got the blue represents this node, which is PMSAN6, just the host name, right? And yellow, which is PMSAN5. So two storage units. And these things here are the resources, everything that's sort of sitting under there. So we've got an IP address, an iSCSI target, an iSCSI LUN, and basically some like post-up scripts or some post-up actions that happen. Sitting below that, we have DRVD, which is a whole nother talk in itself, but replicated block level storage in Linux, very easy to manage, really good. So we've kind of got what this builds to is three LUNs, so three storage LUNs that are available in this particular HA system. So you might have LUN 0, LUN 1, and LUN 2. LUN 1 and 2 are running off SAN6, and LUN 0 is running off SAN5. Each node has a resource for the Stonor, which is measuring ready to kill the adjacent node should it not be available. And they have a couple of other little smarts in them, so you don't just go, oh, can I ping the other node? If not, let's just power it off, because that's stupid, and you'd have outages whenever someone bumps a network cable or something crazy. So you can kind of triangulate things and do fancy rules that if I can't ping it for 30 seconds, and there's at least 3 pings dropped, and I can't connect to it via a serial bus, or I can't connect to the API that checks its remote management console or something, you can kind of triangulate that with a shared resource or a cloned resource. And all these things kind of happen in that effect. So first off, the storage has to be there for the IP address to start, and the IP address has to be there for the iSCSI stuff to start, and the post-up scripts last. So while it looks like a lot up there, it's not actually particularly complex. It's just 3 clones of the same thing for 3 different disks. I'll skip over this one really quick because it's totally not suited to a projector. That's how they look under the bonnet. It's more for like if you want to have a look at the slides afterwards, that's the exact design of how the storage units work. And then those things basically. So that's pulling 2 million IOPS right now. And so 2 physical nodes, they're connected together in the storage array. In this case, as I said, it could be on Amazon, could be on Rackspace, whatever, it doesn't really matter. Not you'll get that kind of performance out of it. but each node right there is pulling 1 million random 4K read IOPS. And you can just go and pull one, and all the resources will just shift across the other. And the only thing you'll notice on the client side is like, I don't know, a bit of IO wait for about 2 seconds, 3 seconds maybe, and it'll just go back to pulling 1 million IOPS. So the best way to demonstrate that is with a video. Now, apparently I can press K to pause this, but we'll see how we go. Yeah, who thought K was a good idea to pause a video? So 2 servers as they described. Okay, they both ping their network gateway. So in this case, it's your storage gateway, whatever in your virtual private cloud or whatever. It's the storage gateway for those storage hosts. They can also force the hardware reset of each other via some sort of method, whether it's an API or a physical power off or something disgusting like that. And they have a number of resources. Yeah, I should have just talked over this while it was going. That would make more sense. Come on. I wish I could speed it up, but I'm so scared to press any key in case it just switches to the next slide. So yeah, that comes back to the co-location. Really important. Like, obviously, you don't want like an IP address to start on a node that doesn't have physical storage. And yay, okay, cool. That's the bit I wanted to get to really quickly, which is awful on a projector. Wow, okay. You can look at this afterwards. All the cluster state obviously is not visualized in some disgusting Java app like I just rendered that to you in. All of it's done via the command line. Everything is, I guess, pretty easy to interact with. A lot of the tools, like for example, we bootstrap our entire storage clusters with Puppet. So you want to add a new LUN or you want to add a new initiator, you add something into Hira, and so it's just in YAML, and the whole storage array will just go and provision a new LUN out of the YAML to create all the resources. And so the reason I'm showing you the latency is because it's important during failover. And the IOPS when we get there. So this node here, this is really important. So this is pulling, this is a VM, like millions of layers abstracted from the physical hardware. It's pulling 37,000 write IOPS. It's going along, it's ticking along. So basically just doing a disk benchmark. And so what happens when you fail over under load? So you can see it's pulling 37,000 IOPS, and we essentially pull the power out of the other node. So this is live, and it's happy. We pull it out, and you can see that resources, resources start to shut down on the nodes. They've detected that that's no longer available. And resources, once they've safely shut down, the VM there has seen that it's now just waiting on disk. It's way too small to sound as projector, but basically it's just got disk weight. So it's sitting there going, oh, my storage is slow, this sucks. And the resources up in the top left-hand corner have actually all just switched across, and now you see that the LUN 0 has switched across to the other node, and nothing is running on the other SAN, and the disk weight's just gone, and it's just back up to where it was, which is quite nice, because as I said, you only end up with like a couple of seconds of latency, I guess, disk latency. It's the kind of stuff that we see on our HP SANs and general usage anyway, to be honest. And failback, which is always the hardest part of clustering, is really simple thanks to DRBD and the Linux cluster framework, because when the other node comes back online, let's say you do a reboot, and so it's got old data, it just comes back online, Pacemaker sees it as being back online, and hey, you're back online, are you healthy? Yes, you are. And then it goes, cool, can I sync the storage across to you? Yes, I can. It brings all the storage up to play, and you'll see that once they're all up to play and it's deemed back online, the LUN just comes back online and then finishes the video too quickly. I'll skip through this really quick. So yeah, back at the start there, so you've got a virtual IP and a service managed by those across 2 nodes, and what you want it to happen is, just like I just showed you just then, that node blows up, everything switches across to the other node. Really simple to install. If you're running CentOS 7 or Fedora newer, if you game, basically those are pretty much the only packages you need for the base HA install. This is more in it for afterwards if you want to start having a look through the slides and see where you need to go. There's not a lot of config in the base core sync config. And and there's only 2 services that you need to manage for the whole cluster. So it's not like you're running, it's not like Mesos or something like that where you're running like millions of different services all over the different place, and that's for a different purpose. But you don't need to, I guess, you just need to make sure that 2 services are up. So it's not that scary to sort of manage. Creating resources is really simple. So you want to create a floating IP, that is it. That's actually it. Like that will just start an IP address on the current node that you're on right there with 1051.10.150/23. That will just work. That will also, if it's able to, it will also just fail over to the other node as long as your base config is set up correctly. And creating any systemd resource, whether it's logs, dash, or postfix or something like that, is pretty easy to manage as well. It's not going to manage all the data from those services. It's purely going to stop and start the service and measure whether it's running healthily or not. Oh, let's skip through most of this, I think. Pretty boring. Key message to take away, like you must use fencing, so stoneth, like they shoot the other node in the head, and making sure that you properly co-locate your resources on the same physical nodes in your config. I can't stress how important that is. If you go into the Cluster Labs IRC channel, the first like MOTD that's constantly there, it's before you ask any questions, you must be using stoneth, you must be using resource fencing. Read the manual. Here is the manual, you know. And once you get past that and you are actually running those things, those people are great to speak with. And testing failover, like, you know, like if you want to do test-driven failover, it's so easy. It's just like a couple of commands, which is actually what I ran before in that video. Standbying a node is kind of the same as just turning off a node. It's not the same as ripping the power out of the disks, but it's the same as just going halt without giving any information to the services running on it. Yeah, you just end up with everything failed across the other node. So, like I was saying right at the start, like this is just total high level, really shit talk because I've done no preparation or anything on it. That is like the key thing that you should go and look at if you just want to make a service available in 2 places in Linux, across 2 different servers, 3 different servers, however many different servers. You don't even need necessarily like a cluster of 3. You don't need the traditional quorum. You know, like you need NTP. You can never have just 2 NTP servers. You need 3 and that kind of stuff. You can make quite viable, I guess, redundant servers or redundant clusters with just 2 nodes, as long as you have correct and like properly thought about resource fencing and stoneth in place to protect and isolate services from starting in 2 places. It really is. I can't stress how easy it is. I really wish I'd known this stuff like 5 years ago, because there's so many things that I'd written custom like post up scripts for, and just the other day we were like going to set a virtual IP up for something. It's like, why are we going to do that with CARP? Like, why are we going to edit like EDC network interfaces or sysconfig, ifconfig, you know? And it's like, why are we going to do that? Just chuck it in ChorusSync and let ChorusSync handle all the IP failover and everything. And then it's like, oh yeah, and then we can just make sure that that service doesn't start before that. And suddenly we're not writing a whole heap of Puppet manifests to do this and that and ensure the state of various services. You're kind of just letting the cluster handle it, which it's really good at. So yeah, I highly recommend the Cluster Labs doc. A bit of background information from that clustering and open source ecosystem, because as I said, like if you just jump on Google and you start Googling for how do I cluster X or something like that, you're going to get really old, crappy information. You'll get misinformation. You'll spend hours going down the wrong track. The 2 stacks that it works really well in, so CentOS 7 or Red Hat 7, it does work in obviously 6 and stuff really well as well, but it's old information. Don't even try it on Debian. I'm not even going to talk to you if you run Ubuntu. But yeah, SUSE or SUS, I don't even know how do you pronounce that?
SUSE.
SUSE?
SUSE.
Okay. That is also a really massively stable clustering distribution. The guys there done great work on clustering. It's been really rock solid for us. So the worst thing about clustering is my talk tonight. So I guess I can answer any questions quickly, but that was quite a long talk. So.
Do people tend to run many resources on a cluster, or would you separate it out to? Would you separate it out so you have just like failover pair for any single resource without complicating?
Yeah, people run some really massive clusters with quite complex designs, and I think probably you'd only want to do that once you understand the basic concepts, like anything, right?
We did it with not ChorusSync, pacemaker, etc., not the clustering solution, and we. It seems to have been done for cost reasons a long time in the past. Large machines, small clusters of 2 or 3 or 4 machines per cluster, many resources. and it's really problematic.
What do you mean by a resource?
So an NFS server, an FTP server that's acting on a different file system, so not dependent on that NFS server, completely unrelated things. And
I don't know what the software is they were using, but like if you were to do like, say you had NFS, NTP, Postfix, a file system, Apache, and something else, right? Or whatever, right? You could run all those on a 2-node cluster quite happily without a problem if you. That was my best tweet. That was really good. Thanks. So
the problems we practically come across are things like your source address routing. So you'll send out a packet. It'll come out of one interface with one source address, and then all elsewhere.
What you're dealing with there is like the clustering framework itself, probably. I mean, or standard Linux networking problems that would occur if you're running those services on there anyway. Not so much like the controlling and the failover and the management of those tools.
True. But my point being that in practice it might be better to use just failover pairs with individual resources, going micro architecture sort of thing. Just simplify your clusters as much as possible. Only do the one job with your failover. Make it a small VM.
I would simplify them as much as I would anything else that was going to run on the same VM. Which for like I haven't done anything like run the NFS and all that kind of stuff on one thing. Like for us, it's like storage, IP address, and iSCSI, which is like the bare minimum thing you need to run there. So I'd probably agree with you. I mean, I haven't tried that. I mean, in theory it would work, but it sounds to me like that's probably more like core network Linux like concepts than the actual management tools.
Yeah.
But I don't know what they are. Anything else?
Yeah, Coruscant, for the messaging, have you, I know it's coming back to this is your 2-node storage, your 2-node storage cluster. Are you just running the messaging layer on one network interface, or are you running it on multiple?
Yeah, so we have a dedicated network interface that is purely for, not just for messaging, but also for replication, so data replication. Yeah, exactly. So we've got 20 gigabit LACP bond for DRVD replication, and for it also has the Coruscant messaging layer running on it, and a correct. But you can, and we did when we tried that. There was no great problem. I think a lot of it comes down to latency more than anything. While I say that I had 20 gigabit for that and 20 gigabit on the other side, you don't need that. Like you can run it across like massive WAN links. Just don't read GitLab's article about they decided that they were going to do a lift and shift from physical hardware and like I don't know Antarctica or something to like I don't know AWS Sweden or something. I don't know whatever the hell. But they did it for some ungodly known reason. Did it with DRVD block replication, and they're like, oh, it's so slow and stuff like this, and they're like, what the hell, man? Async, like you're just moving files from A to B. That really comes down to like I think the network latency. And if you are building any complex system or any replicated system in two physical or network locations, and there's going to be latency between it, you have to accept that latency. You have to give it time to catch up if you're going to do a failover. And that's the only thing I can see really with running on the same network. There's plenty of people that just have 1 or 2 NICs.
You're running link aggregation. You've got isolation in case there's a problem with one of them.
That is true. Yeah.
So the minimum number solution where you've got a single network cable for someone to snap.
Yes.
That's like.
If you cut the dedicated Coruscant connection between these 2 nodes, all the resources would shut down cleanly actually on these ones, because they can't ping each other, but they can ping the gateway, which comes back to that like sort of like triangle of truth sort of thing.
That's it.
Yeah.
Yeah. Thank you, Sam.
Yeah. So
we'll be around afterwards, obviously, to answer any more deep, dark questions.
Thanks, Sam. I feel like saying Brody leaving cluster.
So next up, we got
That would be
Colin talking about
Cephalopod.
Cephalopod.
I'm like tempted to start playing with the light switches. There we go. That's better.
something blows up.
Yeah, boom. Well, it's not blowing up here, so that's all fine. As long as it's blowing up somewhere else, I'm happy. So, for those of you who don't know me, I'm Colin Homestead. I work for REA. I'm the Global Infrastructure Lead, which basically means that I'm a manager nowadays. You be careful. You never know what might happen. So some of my team in here, for which I'm very happy. But I'd like to share with you something that I've been working on for the past few months, off and on, in between playing with PowerPoint, which is Shufflepod. And the idea is that SSH key distribution sucks. So let's not do it at all. So the main problem with SSH keys is that they are persistent. They last forever. There's no timeouts on them. And so you have to think about, how do you deal with rotation? I've distributed a private key to a whole bunch of people, and now I have to tell them, oh, here's the new private key. Or people have given me their public keys, and I've put their public keys in a place, and now they've generated a new one, and I need to rotate that. That's a giant pain in the ass. And if one of them leaks, I have to revoke it, and I have to make sure I've revoked it everywhere, and it's just an extension of the rotation problem. I need to worry about how I'm actually going to distribute these keys in a secure way from one place to another. Whether it's private keys or public keys, I have the same problem. I need to be able to get them from wherever they were generated. And most of the context that I'm talking about here is Amazon, but it'll work just as well inside a data center environment as well. You have the same problems. So how do you actually get these things safely and securely out there? And once they're out there, what do you do with them if you need to do something if they go rogue? There are a variety of workarounds that people have come up with. X509 certificates would be fantastic. If only SSH supported X509 certificates natively. It doesn't. There is a very well-maintained fork of OpenSSH by a guy from Romania. He's done a lot of work. He's made a lot of contributions to the OpenSSH source tree, but it is a fork of OpenSSH, and you're going to end up maintaining something that's out of the mainstream, out of the main tree. You're going to be looking after it, looking after your own repositories. There's no RPM repository that you can add. You've got to build your own packages for it. That doesn't sound like very much fun to me. You could go password only. Screw SSH keys. Just do passwords. Okay, everywhere. Well, that's great, but if you're talking about an EC2 instance in a private subnet that's not connected to your central identity authentication store, then you've got a layer 3 connection problem, and you end up with everything tunneling back to the center, and you kind of don't want that because you're poking holes through things where you shouldn't have to poke holes. SAML, hooray, SAML would be fantastic, because then we could use a trusted third party, cryptographically signed and secured, and maybe there are PAM modules for it. Yeah, not really. Kind of annoying. There are some PAM modules that sort of do things with SAML, but they don't really do it very well. So what else do we do? Well, we can have people give us their public keys, and we can put them in LDAP. That'd be great. Except we need a layer 3 connection to our LDAP server to check whether the public key is valid for this particular user. So that's the same problem again. We can use scripts, and we can pull the SSH public keys out of an S3 bucket or down from a website. They're public after all. You can print them as QR codes and wear them on your shirt. Use a webcam to recognize it as you walk past the window. That would work. That was fine. But then you end up with authorized keys files full of public keys, and you have a revocation problem again. And you don't have any end-to-end identity with this either. You don't actually know who is presenting the signature of the challenge signed by the private key. It could be that I leave my laptop on a tram and someone backdoors the fingerprint reader and gets my private key and is logging in from somewhere else. It's not actually me. If only there were some kind of trusted third party, you know where this is going, right? That could give you time-limited credentials, that did not require a layer 3 connection from the instance or the VM that you were logging into back to the source of identity. That was trivially simple to configure and gave you that end-to-end identity assurance without having to add anything extra. No external forks, no custom PAM modules. Wouldn't that be wonderful? Well, as it turns out, X509 certificates support in SSH is not really a viable option, but SSH keygen that we all know and love has the ability to sign public keys. SSH keygen can be a certificate authority. Once you realize that, it all starts to come together. So, there are a number of publications, bits of prior art that people have put out. DigitalOcean has a guideline on how to use SSH keygen to sign SSH public keys to get into your droplets. Cloud Tools wrote SSH Cert Authority, which is meant to be a democratic SSH certificate authority. But it requires integration with a variety of external tools. Skylorio.net, using a certificate authority with SSH. There's a bunch of work that's already been done. What I'm doing here isn't shiny and new or exciting really that much. I'm just pulling together a few threads which make sense to us. Drawbacks of existing systems. So we don't have support for federated identity with most of those services. There's no end-to-end identity and uncertainty of identity, which actually comes out of that. You need to run EC2 instances, you need to run VMs, you need to look after and manage and monitor these things. And really, they didn't quite fit what I wanted. I was going to have to do extra hacking to make them work, and it was someone else's code. I was going to have to massage into roughly the right shape. It would have been much easier if I could spend that effort building exactly what I wanted in the first place. So, enter the cephalopod. So cephalopod is a trusted third party. It's an SSH certificate authority. It is used time-limited credentials. So I type my username and password and I get a signed certificate that's only valid for a certain number of hours. So the revocation problem goes away. I don't need a layer 3 connection because it's based on cryptographic trust of signed certificates. So my EC2 instance located in a private subnet doesn't need to be able to talk to my LDAP server at all. It's trivially easy to configure. You don't need to add anything really to your EC2 instance other than configuration. And it gives you the end-to-end identity. So you know that it was really me that logged into that instance, not James who stole my laptop.
Damn it, James. Yeah.
And it's supported by every version of OpenSSH from 5.4 onwards. So, as an added bonus, SSH keygen allows you to set options on, or set criteria, requirements on the certificate that it puts on the public key. You can say, for example, no agent forwarding. People who have environments that allow agent forwarding and wishing that they could get rid of that, this is an easy way to do it. It allows you to specify the destination user. You can log into EC2 user, but not Ubuntu. You can log into EC2 user, but not root, and then you can't forward the agent connection on to a host behind it. And there are some workarounds that you can use to make sure that you can hop from one host to another without doing the agent forwarding, so that an attacker on the destination host can't scrape your SSH keyring. It's very lightweight on the client system and on the server side. It's completely serverless. There's no infrastructure to manage or monitor. Amazon does all of that for us. Isn't that nice? So how do we build it? We use the AWS API gateway, which provides a RESTful interface hosted in CloudFront, so it's distributed worldwide, extremely scalable, very robust, very secure. API gateway invokes Lambda functions, which Amazon charges at the 100 millisecond interval, and it's like 26 cents per million invocations, or thereabouts. So it's very cheap, and again, no service to run. It scales out automatically as much as you need. Route 53 for distributing the certificate authority's trusted public key, and also SRV records, so you can work out where to find it. KMS for encrypting the certificate authority's private keys at rest within S3. And CloudFormation to wire it all together. Now, at this point, there is no CloudFormation support for API Gateway, which makes me a bit sad. And so what we have is a rather horrifying accommodation of Docker containers to just build and deploy the thing because of the Maven dependencies on the API gateway importer, which is written in Java. But that's a temporary situation. Eventually, I'm sure CloudFormation will support API gateway and all will be well. So how do you actually configure it? How do you get it up and running? Well, you add Cephalopod as a service provider to your SAML identity provider. We use Okta, but we also use Shibboleth, and I've demonstrated to myself at least that it works with both Okta and Shibboleth. For most SAML identity providers, there's no reason why you couldn't do the same thing, Ping Identity, any of the other popular ones. But I'm only going to show you a demo based on Okta. Okay, so then you deploy Cephalopod, and it's basically make deploy, and you stand back. Now you need to have Docker, but then Docker will grab the appropriate layers and bring in the things, and you need to have AWS credentials, and it will stand up the API gateway, and it will stand up the Lambda functions and the S3 bucket, and all of that sort of stuff for you. Eventually, it'll just be a single CloudFormation stack, and that'll be nice. You make a 2-line addition to the SSHD config on the instances that you want to log into, and you restart SSHD, and that's it. Who wants a demo? Okay, now, I was going to tether and give you a live demo, but now that Sam's set the stage, I'm going to instead cheat and show you a canned one, because this is guaranteed to work. But it is. Oh, you had to say it. Canned demo, unless mPlayer crashes. Yeah, all right. So I recorded this just earlier today. So here we are. I have at the moment an EC2 instance running, which is configured for Cephalopod. And this is the EC2 instance. I'm going to pause it and restart it, but there won't be too many big breaks. You can see that it has no key name. So there is no SSH key associated with this EC2 instance in AWS. And it has a public IP address. Okay, that's great. So no key name and a public IP address. I'm going to find out as well, I'll show you the user data. So this is the configuration for Cephalopod in the user data of an EC2 instance. All we're doing is finding the public key that we're going to trust, sticking it in a file, adding 2 lines to the end of the SSHD config, and restarting SSHD, and that's it. So let's have a look at what that public key actually looks like. It's in DNS, hosted in Route 53, and it's a public key. So it can be public, and we're fine with that. Anyone can look at that, doesn't matter. This is my SSH agent. I'm sorry for those of you at the back who maybe can't see the bottom of the screen. I didn't quite consider that, but it will percolate up. I don't clear the screen each time. So SSH agent is running on my laptop, and I just have my private key. So I'm going to try and log into that EC2 instance now. And it's going to go, uh-oh, denied. Well, of course not. I can't authenticate as myself. So I'm going to run the Cephalopod wrapper. I say I want to log in as the EC2 user to a host in that DNS domain. It uses an SRV record to find out where the API gateway endpoint is. I log in as myself to my company's Okta SAML identity provider. And once it has the SAML assertion, it passes my SSH public key and that SAML assertion back into Cephalopod, which then signs it and gives me back a signed public key. I'm just going to run, actually what I'm going to do first is show you what the signed certificate looks like. So here we have SSH keygen, just looking at the signed certificate there. It has a key ID, which is taken from the SAML assertion. It has a validity period. It's only valid for 12 hours. I can only log in as the EC2 user, and I can't do agent forwarding because those are the only extensions which are permitted. So I'm going to add that certificate to my SSH agent, type my extremely long passphrase, and you can see that it's added the certificate with this certificate ID. And there it is in my SSH agent. Hooray. So now, if I just SSH to the instance, boom, I'm in. But it gets better, because it's not just an SSH key that allowed me to authenticate, it's my certificate ID. So that's where the end-to-end identity comes from. Varlog Secure now contains my email address, which is taken from the SAML assertion. I might faff about here showing you what the contents of the SSHD config is. You see it's just those two lines, just catted onto the end. And the trusted certs file just contains the SSH key that it pulled out of DNS. Okay, so that's great. So, where are we? Risks and caveats. Obviously, this solution is not 100% perfect. Seems perfect. It seems so perfect. But after thinking about it for a little while, I realized, yeah, there's a couple of problems potentially with it. So if you have access to Cephalopod's trust stores, you can update the DNS.txt record. You could put your own public key in there, and then host would start trusting it. If you could update the contents of the S3 bucket that Cephalopod uses to store public and private key pairs, you could submit copies of ones that you own and control. Okay, so for that reason, I recommend using a separate account for hosting Cephalopod, something that you restrict access to. Now, this makes it a little bit less nice, because it would be really wonderful to be able to say SSH EC2 user at hostname.domain, and then have a config in your SSH config file that runs the wrapper automatically and checks to see if you've got a certificate for that host and that domain, and if you don't, it logs you in and all of that sort of stuff. And you could definitely achieve that if you maintain very tight control over the IAM policies in that Amazon account, so that people can't update that Route 53 record and they can't write into that S3 bucket. But at REA, we favor moving fast and autonomy over a lot of control, and so that was something that was probably not going to fly very well, or be hard to manage and maintain in our particular environment. It's not impossible to do it in your environment. You could definitely do that. You just need to work out where you sit on the autonomy versus leverage scale. But it is much, much safer by having it in a separate account. And that was what I was doing there. So you could see that I was talking to skynetdev.realestate.com.au as the DNS domain to find the Cephalopod from. There's a few things yet to be done. I would really like to have it supporting ADFS and Shibboleth. I mean, there's a wrapper script in there that mostly works with our Shibboleth, but probably needs to be made a little bit more generic, because the one we were running was a bit old, and I stopped working on that as soon as I got it working with Okta. Ping Identity and other identity federation providers. I would like to replace the Docker provisioning horror show with just a pure CloudFormation template. One day, hopefully, I will be able to. And I say KMS, but I haven't actually implemented that video. That's okay. But maybe you like an appliance AMI or a VM that you can run in your VMware environment as well. There's no reason why we can't do that too. If you would like to give it a try, it is on public GitHub now as of about 4 o'clock this afternoon. rea.2/Cephalopod. There's a QR code there. Thanks, Sam, for giving me the idea for that. So if people want to take a moment. And kittens, because you can't not have a kitten. Consider it late alpha or early beta quality. It works just fine, but it needs a bit more monitoring, and it needs to be tightened up and maybe refactored a bit. I can see Stephen typing away madly here. He's porting it from Node.js to Python.
Yay.
And
They challenged me.
His goal was to have it done by the end of my talk.
No,
not going to happen.
You talked too fast.
I talk too fast. Not even Stephen can do that. Mainly it's working with SAML, which is kind of a gigantic pain in the ass. So this version is written in Node, runs in Lambda. It just sits there. It's not doing anything until you actually use it. But I encourage you to have a hack at it, give it a whirl, and tell me what you think. Are there any questions?
Yeah, lifetime. Can you adjust the lifetime of the issue?
Yep. At the moment, it's hard coded in the certificate authority 12 hours, but absolutely.
Lucas and about your trust anchors in DNS because that's manual. Would you be able to hard code that inside the house?
Sure. Yeah. Yeah, absolutely. Yeah, you could put the trust anchors pretty much anywhere that it made sense. So you could have an endpoint that you could query with the application to retrieve the trust anchor. The reason why I put it in DNS is that, let's say you have a scenario where you have instances that don't have internet access. They can probably resolve DNS though. So DNS permeates a lot of boundaries that may exist against HTTP or HTTPS requests outbound. But yeah, absolutely, you could have an endpoint that just serves the trust anchor. Yep.
What's the procedure for like a loss of or compromise of root CA, and what's the impact of that?
Right. Well, the simplest thing to do, which is in the to-do list in the GitHub repo, is to have a simple trusted credential renewal script based on the DNS TTLs, or if you're getting a trust anchor from somewhere else, on a TTL that's served out by the trust anchor as part of a JSON document. And so then you can just refresh the trust anchor on a regular basis. If you need to worry about a compromise, you just blow away the current one, create a new one, wait until it's percolated out, and then you're done. You don't need to actually distribute SSH public or private keys from or to users, because users use their own identity, their own private keys, and I can just go and delete mine and create a new key, and then authenticate again, and I'm good to go.
So SSH, obviously put it into a file and then told it to load it at startup. Is that something you just put a new one in the file or something?
Yeah. Yep, exactly.
Any advantages in comparison with setting up authentication, like one-time password?
Advantages over two-factor. You could definitely incorporate two-factor. So you could definitely put two-factor on the authentication stage. One of the things that I'll say about this at the moment is that there's currently no authorization phase. You could easily put authorization either at probably the best place to put it would be within the SAML response that comes back. So you can control what people are allowed to request a signed certificate for. But as far as two-factor goes, that would only occur at the authentication phase. So if your identity provider supports two-factor, yeah, you could definitely do that.
I just about compare to setting up authentication as opposed to authentication with using signed switch key from the point of view of security. Seems like it's the same levels.
It's slightly better than just distributing a private key and allowing people to SSH into an instance just based on the fact that it's something they have, because the something they have is now time limited. So I'm not attempting to provide military grade security or bank grade security on this, although yeah,
That doesn't mean much.
Doesn't. Sorry. Sorry. At the moment, I believe so. Yeah, no DSS. I don't know if there's signing for ECDSA at the moment. So, what you did? Sorry. Yeah. Sorry. Not sure. Definitely something we could have a poke at. Cool. Photo credits because all of these came from Flickr. All Creative Commons. So, thank you.
And finally, we have Bowen. While he's setting up, do you want to do the community things? Or are you ready to go? Ready to go? No. Go ahead. Hold your own.
So I've got some stickers here. Now these are the original stickers. These are very hard to come by. I found them in the back of my in one of my bags. If you want one of these stickers, you need to give me some feedback. We like feedback. They're the new style ones. They're small. These are better. Anyone who wants a sticker needs to give me some feedback about the style of talks, the topics, how we run this meetup, all that sort of stuff.
Needs more stickers.
Needs more stickers.
Needs more original. Don't blame my rant.
Yep, go for it.
Okay, good evening, everyone. I'm Bowen from the Xi'an office. So about 2 years ago, I visited Melbourne, and Infracoder is the first meetup I joined. And I've been here for 3 times, so every time I never miss the Infracode meetup. So I'm glad today I could contribute something to the meetup. Yeah, so the topic is CI solution with resource. So first, let me introduce about myself. My name is Bowen. I'm working in the Xi'an office and mainly working on the RE project because there's a delivery center just for RE. I've been a web and Ruby on Rails developer for 2 years. And after that, I just converted myself into a DevOps for 2 years. The only big things I did is a book translation called Scala Cookbook. But don't ask me any question about functional programming. Thank you. So first, I'd like to introduce the place where I came, Xi'an. So in a recorded history of 3,000 years about China, Xi'an is functioning as the capital for 1/3 of the time. So it's a place rich in history. So as you can tell, the first picture is a terracotta warrior. I do have a colleague who looks like it. But don't mess up. Not everyone looks like terracotta warrior. So if you're not interested in the history, you can also try the food there. The first one we call it hongluo, which basically lamb soup together with meat and slitted bun. And second one we call it rou jiamo, and also you can pronounce it as Roger Moore. And so if you go to Xi'an, I bet you must try it because I bet it's much better than Meruel. And the third part is the landscape. This one is called Hua Mountain. So it's about I think 2,000 kilometers high, and so climbing it is really neat climbing. If you go there, it's definitely a different experience than climbing Dandenong. So basically, I've just introduced the most important part of the topic. So let's get back to the not important one. So when we talked about CI, these are the things that pop up in my mind, like Go by ThoughtWorks and Jenkins and Bamboo. So these are the traditional tools which we need to supply infrastructure to run it on. And second line is the SaaS one, like Travis CI, Snap CI also by ThoughtWorks, and the Circle CI. The third one, BuildKite, I recently just learned about it. It's kind of interesting because BuildKite only supply the server and you run your agent. Yeah. So about 4 years ago, when I joined the RE project, their CI model is like this. So every team, they have their own CI, like a Jenkins master, and all the slaves are running in EC2 as EC2 instances. And you need to, so for each project, you need to run the slave with different environment. So you need to use Chef to do the provision. We have wrapped the AWS SDK to do the instance creation stuff, and also another to just use Chef to do the provision and deployment. And laterally, we switched to Bamboo, and it's look much more production-like. So all the infrastructure are provisioned by CloudFormation, and in each instances of slave, it runs a CFN hub, listening for the change of metadata. If there's any config change, it will just re-provision the instance. or the slave. So it's good for REA to keep using the CI, because it just insists on doing the continuous delivery, continuous deployment with the CI. But to me, I think there's some cons. So first, the slave is quite fat because you need to grant it all kinds of capability to run the different jobs. So you need to install everything like Ruby 1.9, Ruby 2.0, JDK 1.7, JDK 1.8. It's kind of fat, and the environment is quite coupled because I need to run a Fathom.js test. Then I need to. Then it depends on the federal agent to run it. And also the utilization of slave resource is low. Like Bamboo agent, you can only run one job in one Bamboo agent at the same time. I know Jenkins seems to have some kind of configuration to allow you run multiple jobs in one instance, but it's kind of like static. It's not dynamically allocating the resource. So and also if the config chain fail, it blocks everyone. So if there's some incident happen of the Bamboo agent, so both the developers and the people who look at the Bamboo environment will just go crazy. And also, so to me, it's like probably it's not a good idea to separate the resource, because we can treat that. I've joined some conferences and meetings in China. So far as I know, they treat the resources like the CI stuff as a whole. So they supply a unified resource or infrastructure to running the CI stuff. But we do it separately. Like we have several different Bamboo environments. Yeah. So we have pains. How can we improve? Actually, the answer is in the internet. It's a existing solution. So Mesos plus Docker plus Jenkins. Of course, you can replace the Jenkins with other CI tools. So assume everyone here have known about Docker and Jenkins. I'll just do a brief introduction about Mesos. So it's like it is a CS structure, and it basically treats your data center or infrastructure as resource pool. So say there's a framework, it have implemented a scheduler. So when your framework wants to running some kind of task, it set a request with the scheduler to the Mesos master. So the Mesos master will help will do some calculation, means how to best utilize the resources in its slave, do a balancing, then run a task with the executor to run a task on certain slaves, and all the tasks running in the slaves, they are separated, they're not affected. So the solution, the CI solution is like this. When there is a job triggered, so the Jenkins master will use the Jenkins scheduler to apply resource to the Mesos master, and Mesos master will just schedule the resource or apply the resource to certain slaves and run the execute of Jenkins. Then it started Docker instance to within the container. It just started Jenkins slave, use the Java Web Start way, and then it just run the job and return the result back to the Jenkins master. And if this resource is not useful, after a while, the Mesos just revoke the listing. So the demo. I'll just so in talks we have the saying showcase must fail, but I'll just try my best. So here I just run everything in one Vagrant VM. So here is the Mesos master, and it has a slave, here. But actually they're running in the same VM. So in the end of Jenkins, you need to configure this. So firstly, you need the Mesos scheduler here. So you need to install the plugin first. Yeah, sorry. And then after that, you need to configure the Mesos cloud or Mesos scheduler here. Just a second. You seen it?
Can you put it on the top of the screen?
What do you mean?
Move it up.
Here?
Yeah, so people on the back.
Yeah, so here is the Mesos plugin. So you need to configure Mesos native library, and also you need the address of the Mesos master. So here it just fetch the Mesos master from the Zookeeper, and as you can see, it's a Jenkins scheduler. And after that, if you click it once, so you can do some label things, and here's the request of resource for running a Jenkins slave. And if you keep clicking, so it requests to use Docker container. Thus, if the Mesos master wants to start a slave, want to execute on the slave, it will just use the Docker to spin up a spin up a container. And I define a Docker image here. So yeah, it's a Java image with JDK 7. So here it's the actual job. On that configure is that restrict the project can be run with the instance or slave labeling as Java. And the build job is actually quite easy, just show the version of Java. So if we just click build, so the job has set request to Mesos master for spinning up a new Jenkins slave to run the job. So here, just a second. So here is a Jenkins slave running in Docker. And yeah, the job finished very quickly. So it will show the version of Java. Yeah. So after a while, I believe it's like 3 or 4 minutes or 5 minutes. It will just kill the container, and remove the resource. So what are the benefits? So the Mesos slave only need Docker running and the slave running. It's simple and less likely to fail. And on the environment and jobs, they are separated. If something is wrong with one of the jobs, it doesn't affect other jobs. And the utilization of the slave resource is relatively high. So presumably, because I didn't run with the very large scale of it. But I believe some of the companies like eBay and also Twitter, they've used it very largely in their data center. Yeah, so that's all. Very simple. Questions?
So what if your project you're running is itself a Docker one? You'll end up with Docker in CI, right?
No, not Docker in Docker. It actually just Docker. So that image is a Java image. So in that image, when they spin up the Docker, the container, it just run it with the Java web stuff mode. So yeah.
Okay. Right.
It's not a Docker in Docker. I've seen the solution for Docker in Docker. I think I don't quite like it.
Yeah, I don't like Docker in exactly.
I've got to believe. Security breach. Do you have a solution for scaling out the underlying instances? For scaling?
Scaling? I think that I'm not quite sure, but there's some other.
Fixed number of hosts.
Okay, I think you can combine that with other things. If you are running that in AWS, you can use auto scaling group. Yeah, I like that. And I think there's some other components together running with Mythos, such like Marathon. But one of my colleagues says Marathon is too easy. Maybe switch to Kubernetes and Swarm. Yeah. Not too easy, it's just too simple. Yeah, so in the perspective of functionality. Yeah.
In one of your earlier slides, you had the resource scheduler calling out to the Hadoop scheduler. Do you have an example of like a good way to do that? Is there
example what?
In one of your slides at the start, you had resource calling out to the Hadoop scheduler.
Yeah, which one?
One. So you've got Hadoop scheduler up there. What do you mean by that? Is that actually going to a yarn scheduler somehow?
Oh, what do you mean? Can you? Yeah. This one or this?
Yeah.
This one?
Yes.
I don't try to run this, so just use Jenkins as an example. Yeah, but I think you can do that because there's exists Ansible stuff. You can find that in internet. Okay, GitHub. That's all.
Last question? All done, no questions. All right, well, Bowen and also Colin will be around, as well as Sam, if you've got any further questions. So the food has arrived, but we'll just quickly do a community announcement. So if this is your first Infracoders, if you've been here before, this is the chance if you're looking to hire or if you want to be hired. If there's any other meetups or conferences or things like that that you think the community would be interested in, put your hand up. And
hi, I'm Brian. Let's a couple of questions quickly. I'm just wondering, firstly, who uses the Atlassian tools for themselves?